In this video, I'll be going through the 2017 paper 2 higher calculator. So let's start. So the first question on here, table 1 shows the probabilities that a biased dice will land on 2, on 3, on 4, and on 5. Name or rolls the biased dice 200 times, work out an estimate for the total number of times the dice will land on 1 or 3. So probability always adds up to 1. In the table, we can, if you add all of them up, so if I use my calculator, 0.17 plus 0.18 plus 0.09 plus 0.15 plus 0.1. So if I add all the probabilities up in the table, all these, they add up to 0.69. So if I do 1 minus 0.69 and minus 0.69, that gives me 0.31. So that means this must be 0.31. So now the probability for 200 rolls, so the probability that it lands on 1 is going to be 200 times 0.31, and the probability that it lands on 3 will be 0.18 times 200. So that becomes 200 times 0.13, which is 62, 0.18 times 200, and that is 36. So that's 36 plus 62, which is 98. Moving on to question 2. On Sunday, some adults and some children were in a theatre. The ratio of the number of adults to the number of children was 5 to 2. Each person had a seat in the circle or had a seat in the stalls. 3/4 of the children had seats in the stalls. 117 children had a seat in the circle. There are exactly 2,600 seats in the theatre. On this Saturday, were there people on more than 60% of the seats? You must show you're working out. Okay, so it seems like a difficult question, but it isn't one. So if you write this out, so we have adults there, and we have children. And we've been told they're in the ratio of 5 to 2. That's right there. So it says 3/4 right here of the children were in stalls, and 117 had seats in the circle. If 3/4 are here, that's 75%. That means the rest must be here, which is a quarter. So we know 1/4 is equal to 117. So we know altogether there's going to be 1. So we times that by 4, times that by 4. So altogether the kids are going to be 117 times 4, which is 468. And if that didn't make sense, what I've done there is, I know 25% is a quarter, and I want to find out how many kids there are altogether. So to go from 25% to 100%, you times by 4. So that's why I've times each side by 4. Now I know how many kids there are. I can write that underneath here. So there's 468 kids. Well, how many adults are there? We know the ratio is 5 to 2. So how do you go from 2 to 5? You just times it by 2.5. So we're going to times this by 2.5. So times 468 by 2.5 on your calculator, and you get 1,170. So in total, there is 1,170 plus 468. So that becomes plus 468, 1,638 people on seats. So now we know how many people there are on seats. The question says, were there people on more than 60% of the seats? So we know in total there's 2,600 seats. So let's do the maths. That's 1638. Divide that by 2,600 to work out the percentage. Times that by 100. That gives me 63%. So were there more than 60%? No, there were not more than 60% on seats. Moving on to question 3, the diagram shows a prism with a cross-section in the shape of a trapezium. So we've got the front elevation, we've got the side elevation. On the centimeter grid below, draw the front elevation and the side elevation of the prism. Use the scale 2 centimeters to 1 meter. So the front elevation, if I just quickly grab my highlighter, is this here. Oh, it's a little bit bent, that line I drew, but that will do. And that there. So that's the front elevation. We'll first start by drawing that. So if I draw that here, if I pick a point to the left, like that one there, I know it goes 2 meters across, but I know that 2 meters, it's using the scale, that scale there. So times the meters by 2 to get it to centimeters. So 2 meters will be 4 centimeters. So that'll be 4 across. And now if I look at up, so it's half a meter up, which will be 1 meter that way. And then if I look finally at this side, that's going to be 4 up from here. So if I now connect all them points together, of course, you'll do this using a pencil and a ruler. If I connect them as nicely as I can, there we go. That's off a little bit, but there we go. That is the front. And then it says the side elevation. So the side elevation, again, if I use my highlighter, the side elevation will be this, this, that, that, and it will also be all of this, and till down there, and from there till down there. So the side elevation is all of that. So if I draw that, go back here, I'll draw that in blue. So we can see at the bottom here, it's 1, so that becomes 2. So let's draw 2 across. I can see on the side, it's going by a half, so that's going to go 1 up on each side. That's 1 up on this side, 1 up on this side. And I can draw the line across. That's this line here that I've drawn. And now we're left with the top part. So we know that it goes up all the way. It goes up 2 meters high. So we know that the height from here till up there is going to be 1.5. I can times the 1.5 by 2, which gives me 3. I'm just going to go up by 3 from there. And it will look something like this again. I'll draw this with a pencil in the exam and write the word side on top so it's clear what's what. Ollie drives 56 kilometers from Liverpool to Manchester. He then drove 61 kilometers from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometers per hour. Ollie only took 75 minutes to drive from Manchester to Sheffield. Work out Ollie's average speed for his total drive from Liverpool to Sheffield. Okay, so with this question, it looks like there's a lot going on, but again, we'll break it down and tackle it in steps. So let's say he started at Liverpool, write that there, and then he went from Liverpool, he went to, let me just use a different colour, he went to Manchester. Let me just go back to my blue. So I'll just write Manchester there. And then from Manchester, he went to Sheffield, which is a little bit further, but we can draw that there. And if I use my blue point again, so then he went to Sheffield. Okay, now let's write down what the question's given us. So in this case, we're told it's 56 kilometers from Liverpool to Manchester, so let's write that down. So the distance is 56 kilometers, and we know the distance here is 61 kilometers given in the question, so that's on that line there, that line there. Ollie's average speed from Liverpool to Manchester was, so we've got his average speed as well, which is 70 kilometers per hour, so that's that line there. And it only took 75 minutes from Manchester to Sheffield, 75 minutes. And that's line there. So I've gone through the question and I've drawn this out. Work out Ollie's average speed from Liverpool to Sheffield. So you've got to remember the equation for speed, distance and time. So speed is equal to distance over time. So to work out his average speed, we need the total distance, which is 56 plus 61. So that's the distance from Liverpool to Manchester and Manchester to Sheffield. And then we need the total time. So notice the answer is in kilometers per hour, and that's in minutes. So this is equal to, if you do 75, divide that by 60, and that'll tell you this is the same as 1.25 hours. So we can say that's 1.25 hours. Now we don't know, this is the bit that's missing. We'll call it X. We don't know the time it took from Liverpool to Manchester. That's what we need, and we've solved this question. So let's find the time from Liverpool to Manchester. So on this side, I'll write Liverpool to Manchester. We have speed is equal to distance over time. So we know the speed is 70. We know the distance is 56. We need the time. So we rearrange this equation, and time is 56 divided by 70, which is 0.8 hours. And now we know what X is, so we can solve this. So that's 56 plus 61 over 1.25 plus 0.8, 56 plus 61, divide that by 1.25 plus 0.8, and the answer becomes 57.07 kilometers per hour. There's your answer. Next question. Jamie drove from Barnsley to York. Jane's average speed from Barnsley to Leeds was 80 kilometers per hour. Her average speed from Leeds to York was 60 kilometers per hour. Janie says that the average speed from Barnsley to York can be found by working out the mean of 80 kilometers per hour and 60 kilometers per hour. If Janie is correct, what does this tell you about the two parts of Janie's journey? So we know that speed is equal to distance over time. So she's working out the average using that. So the time taken, so we can say that the time taken for both parts must be the same. Question 5. ABC and EDC are straight lines. Okay, EA and DB are parallel, and we can tell that because they've got arrows on the line. And then now we'll start labeling on what they've given us. So it's saying EC is 8.1, so let's write that on. E to C, well, let's not draw that one on, that one's the full length across. Let's see what else they've given us. D to C is 5.4, okay, let's write that one down. Now notice I can figure out what E to D is because E to D is going to be 8.1. I'll actually write that properly, so that E to D is just going to be 8.1 minus 5.4. So if I did 8.1 minus 5.4, I'll get 2.7. So this is 2.7. And then it says D to B is 2.6. And that's that one there, 2.6. Okay, work out A to E. Now it might not seem very obvious how you can tackle it. And the best, hopefully you've started thinking about similar shapes in this case, and you can see it's a triangle drawn on top of a triangle. And if that's not obvious, I can draw them both out separately because it is a little bit hard to spot this. But once you do spot it, the question does become really easy. So if I was to draw that, that, and that, and if I label that, so that's B, C, and D. And let me just write the numbers in as well. So that's 5.4, and that's 2.6. And now if I draw the bigger triangle out, now this is a little bit harder to spot. Should have used the same color really. Let me just go blue. So if I now draw the bigger triangle, that, and just straight line there, awesome. So that then is going to be, let me just fix that 1 second. There we go. So that is going to be A, C, and E. And now if I label the sides it's given me for that one, so that would be 8.1 here. And that is all I have. And that's enough now. So these two shapes are similar. How do I figure out A to E, which is this one here? So we'll label that again. X, what we don't know. Well, one way you can look at it is, you know what the bottom bit here is, and you know what the bottom bit here is. So how do I go from here to here if they're similar shapes? Well, we can do 8.1 divided by 5.4, and all we have to do is times this by 1.5 to go from there to there. So to go from there to there, we also scale this shape by timesing it by 1.5. So do 2.6 times 1.5, and that's 3.9. And if I scroll down, it says A to C is 6.15. Okay, they've told us what A to C is. Work out the length of A to B. So if I come back up here, the question's now asking me to work out, let's call this Y. It's asking me to work out what Y is, but it's told me the full length, which is fine. So they've told me A to C, which is the full length, is 6.15. I can put that, if I just rub this bit out so it's a little bit more clear. We know the scalar factor is 1.5 now. So they've told me this side here, let me just use a green pen, is 6.15. If I know this side's 6.15, this side is similar to this side. So if I divide 6.15 by the scale by 1.5, which was the scale factor. That's 4.1. So now we know B to C is 4.1, and we can find out what Y is, because Y must be 6.15 minus 4.1, which is 2.05. So this was a similar shapes one. The first thing you've really got to spot is being able to draw the two triangles out separately, and then just use the scale factor to go across. Next one, Alan wants to invest 25,000 for 3 years in a bank. So we've got personal bank and secure bank, both have a compound interest. Which bank will give Anil the most interest at the end of 3 years? You must show all you're working out. Okay, so let's draw a line down the middle. You have personal banking, so that's 25,000. So that's 2% for each year, so percentage is out of 100, so 100 plus the 2%, so that's 102% he gets all together. If you convert that to a decimal, that'll become 1.02, and it's over 3 years, so we'll cube that, so that becomes 25,000 times 1.02 cubed, which is 26,530 pounds and 2 pence. And if you went with secure bank, so in the first year it's going to be 100 plus 4.3, which is 104.3%. So let's times that by 25,000. So this is just in the first year, so we're just going to do it once. So that's 1.043, pop the decimal twice to the left, and that becomes 26,075. And now we're going to take the 26,075, and we've been told over the next 2 years there's 1.09, sorry, just 0.9%. So that'll be 100 plus 0.9, which is 100.9%. So that'll be 26,075 pence times 1.009. Square that because it's over the next 2 years, and that equals 26,546 pounds. And you can leave that as that. So we can see now the difference between the two. This number is higher than this number, so secure bank is a better one. So you can just write a little statement here: secure bank will give Anil the most interest. Right, n is a number rounded to 2 decimal places. The result is 4.76. So the way I like to do this is it's rounded to 2 decimal places, so that's 0.01. We can do 0.01, divide that by 2, that becomes 0.005. Now add 0.005 to 4.76, and that gives me 4.765. Take away this number from 4.76, and you get 4.755. And then in between it, you're left with your inequality. Now, if you think about it, can the value be 4.755? What if I round this to 2 decimal places? Well, that becomes 4.76. That's fine. So we can include this one, so that becomes less than or equal to. And can the value be 4.765? Well, if I round this to 2 decimal places, it becomes 4.77. So it can't be this. So it's not included. So we don't need to put that sign here. So that becomes 4.755 less than or equal to x less than 4.765. If I now scroll down to question 8, the cumulative frequency graph shows some information about heights in centimeters of 60 students. So this is for 60 students. Work out an estimate for the number of these students with a height greater than 160 centimeters. So if I use my ruler and go to 160, draw a line up from there. Just use a different color. That goes till there, and if I just rotate my ruler and draw a line across, you need to be very accurate with this. Oops, let me just, as I say that, I've made a mess of it. Why does it keep doing that? Let me just try one more time. So draw a line across, nice, and I get rid of my ruler. So that is 48 there, so that will be 60 minus 48, which is 12. So 60 minus 48, which is 12. The diagram shows triangle A drawn on a grid. Carl reflects triangle A in the x-axis to get B. He then reflects B in the line y is equal to x to get C. Amy reflects triangle A in the line y is equal to x to get D. She then goes on to reflect D in the x-axis to get E. Amy says that E should be in the same position as C. Is Amy correct? You must show how you get your answer. Now, with this question, most of the marks are given for the working out on the graph. So in order to figure out whether she's right, we need to carry out all these steps. So the first step, excuse me, is this one here. So that Kyle reflects A in the x-axis to get B. So if you reflects A in the x-axis, so just to highlight where the x-axis is, that there is the x-axis. So if I reflect it in the x-axis, we're going to go down one. If we've gone down one, we're going to go down one again. So the first point is that one there. And then we do the same with the rest. So with this point, it's 1, 2, 3. So we're going to come down 1, 2, 3. So that then goes there. And then with the last one, which is that point there, we go 1, 2, 3, and then 1, 2, 3, and then that goes there. And then that looks something like this, and that is B. You can tick that off. Obviously do this with a ruler and a pencil. So that's B. That's the first one done. It says he then reflects the triangle B in the line y is equal to x to get triangle C. So draw the line y is equal to x, go straight through there, and all them points. You need to make sure this line is more or less perfect. So if I draw a line through there, I think it could have been a little bit better there. So if I go again, just make sure it's on perfectly so it's 100% accurate. And now if I draw my line on, there we go, that is perfect now. Just get it on my ruler. So again, now we're going to reflect B and Y. This way you have to be a little bit careful. Again, I'll draw the guidelines on because they do help. So 1, 2, 3, 4, 5, 6. So we've gone 6 that way, so we're going to go 1, 2, 3, 4, 5, 6. So that's my first point, which is going to be there. Now if I go to the next one, so that's there. So I know with this one, it's just one extra hop. So it's going to be 7, so I know that one's going to go there. And then finally, if I take this last point that's left, that's 1, 2, 3, 4, 5. So it's going to be 1, 2, 3, 4, 5. So that point is going to go right there. And if I connect all 3 of them, it will look something like that. And that is C. And now I'm going to rub off these guidelines. So that's that one done as well. And then it says Amy reflects triangle A in the line y is equal to x. So triangle A is right there. So this point here stays right there. This point, 1, 2, 3. So it goes 1, 2, 3. That point goes there. And then finally this point back here goes 1 across, so it'll be 1 up. So that comes right up here. And if I connect them all, that, and that, and if I rub off my guidelines again, so they're not in the way, and then that becomes triangle D, so we can take that off as well. And then it says she is then going to reflect D in the x-axis to get E. Okay, so now we're going to reflect D where the yellow line is. So if you take D, that's going to go 1, 2, 3 down. You're going to go 1, 2, 3 down. So that point's going to be the exact same point there. And then with the other one, we can see it's going to be 1, 2, 3, 4. So that's going to be 1, 2, 3, 4. So that's going to be right there. And with this last point, we can see it's just hopped 1 extra time compared to the other one. So that's just going to go down here. So that will look something like this. So that is that D? No, E, sorry. That is E. So if I rub off my guidelines again, now it says, Amy says that E should be in the same position as C. Now we can see that E is not in the same position as C. So is Amy correct? So here we can just write no, she is not correct, see the graph for the working out. And most of the marks in this question are for what you've drawn on the graph anyway. So next one, the table shows some information about 8 planets. Write down the name of the planet with the greatest mass. Now the mass column is right there. Now it can be tempting. Luckily they're all one digit numbers, and it can be tempting to think that's the biggest number because it's got an 8 in front of it. But the biggest number is the one with the biggest power, so that's going to be Jupiter. And then it says work out the difference between the mass of Venus and Mercury. So Venus is there, Mercury is there. Work out the difference between the two, so that'll be 9.17 times 10 to the power of 7 minus 4.14 times 10 to the power of 7. Type that into your calculator and you'd get an answer of something like 4.5388 times 10 to the power of 24. So it says, Nishat says Neptune is over 100 times further from Earth than Venus is. Is she right? So if you come back up here, we can see Neptune is 4.35. So if you just write that here, Neptune is 4.35 times 10 to the power of 9. And Venus is 4.14 times 10 to the power of 7. So it's saying that Neptune is over 100 times further than Venus. Well, is it 100 times further? Well, we know that's what Venus is. If I times that by 100, that becomes 4.14 times 10 to the power of 9. And that is less than that. So that means her statement is true. Yes, she is right. And you can see the working out's done there. So we've compared, and you can just write a statement of 4.35 times 10 to the power of 9 for Neptune is greater than Venus, which is 4.14 times 10 to the power of 9 when it's multiplied by 100. So next one, solve this fraction. So we have 3x. Okay, cool. So with this one, you want to first, as you do want to do with most fractions, you want to make the denominator the same. So if we start off on the left, if I write the equation out, so that is going to be 3x minus 2 over 4. I'm purposely leaving space here. Is equal to 1 minus x over 6. Now on the left hand side, we want to make the denominators the same, like I said. So we're going to times the top and bottom here by 4, and that 4 is coming from there. And on the right, on the left, I'm going to times the top and bottom by 3. Now this makes no difference if you're wondering, well, why am I not doing it to the right and to the left? Why am I just doing it to the left? Because multiplying by 3 over 3, that just cancels out and becomes 1. That's the same as multiplying something by 1. It makes no difference. So this now becomes 3 bracket 3x minus 2 over 12 minus 4 bracket 2x plus 5 over 12 is equal to 1 minus x over 6. And now this can be written as 3 bracket 3x minus 2 all over 12, because the denominators are the same, minus 4, 2x plus 5 is equal to 1. And we can write that as that. And now what we can do is we can move this over to that side by multiplying by 12, and we can move this over to that side, and that means we're left with no denominator. So that then becomes, I'll use brackets here, so that'll become 6 bracket 3x minus 2 minus 4 bracket 2x plus 5 is equal to 12 minus, I'll just expand it, 12 minus 12x. And now we'll expand this out, so that becomes 6 bracket, let's expand the inner bit out, 9x minus 6 minus 8x minus 20 is equal to 12 minus 12x, and then that becomes 54x minus 36 minus 48x minus 120 is equal to 12 minus 12x, and simplify that, and that becomes 18x minus 156 is equal to 12, and then that becomes 18x is equal to 168, and then when you divide 168 by 18, you're left with 28 over 3 as x. And you can always, I'd advise you to substitute this back into this in your calculator and make sure the left is equal to the right to make sure you got the right answer. Next, 12. There are 30 students in Mr. Leah's class. 16 of them are boys. 2 students from the class are chosen at random. Mr. Lee draws the probability tree diagram for this information. That's first student and second student. So write down one thing that is wrong with the probabilities in the tree diagram. So straight away we can see on the first pick there's 16 boys out of 30. Now if a boy is chosen, and that's right, there's one less boy now, but the total should have changed as well because there's one person has been chosen. So write down one thing that's wrong. So in this case the denominator is wrong. The denominator should be, and it'll be clear, the denominator should be 29 for the second student. So we just, because we want to be clear where for second student. Owen says that Owen and Wasim play for school football. The probability that Owen scores a goal next match is 0.4. The probability that Wasim scores a goal next match is 0.25. Mr. Slater says the probability that both boys will score a goal in the next match is 0.4 plus 0.25. Is Mr. Slater right? Well, to work out the probability that both will score, so the answer is no, because to work out the probability that both will score, it would be 0.4 times 0.25, and you don't add them, so that would become 0.1. And so here we've said no, and we've shown the correct working out, so we can just say 0.1 is the probability of them both scoring. The next question is Histogram shows some information about the ages of 134 members of a sports club. 20% of the members in the sports clubs are over 50, are female. Work out an estimate for the number of females who are over 50. Right, 20% who are over 50 are females. So we want to work out how many are over 50, and once you know how many are over 50, we just need to work out 20% of that. So 50 is right there if I was to draw a line. So we're interested in, I'll just shade it, we're interested in this bit here. And we're also interested in this bit here. So we know that this, from here to here, the base of this is going to be 50 to 60, which is 10. And we know the base on this is going to be 30 to 90, which is 30 here. So that's this bit here. And we know the height of this is 0.567 is 0.7, and we know the height of this is about 1.4. This is 1.4. So that will be 10 times, I'll do that down here, so that would be 10 times 1.4, which is 14. And for the other one, it will be 30 times 0.7, which is 21. So if I do 14 plus 21, that is the total number of people that are over 50, but we know only 20% of these are female, so that would be 7. Here are some graphs. In the table below, match each equation with the letter of the graph. So sine x, you've got a calculator now, so with this one what you can do is, well, what is the sine of 0, for example? So if you type in your calculator the sine of 0, you will get back 0. So hopefully you can tell by looking at these, sine will either be that one or that one, and because the sine of 0 is 0, it's going to be c. So that's going to be c. Now cubic graphs, you should know, look like this. So if you look up here, does any graph look like that? And that's that one there. So that is going to be f 2 to the power of x. That graph is going to be that one there. And if you're not sure what these graphs are, you can always use your calculator and plot out some rough points. So you can be like, what is 2 to the power of 0? Well, you know 2 to the power of 0 is 1. So that's there. And then you can just plot a few points on, and you'll end up realizing, oh, it looks something like this. And then you can go up here and be like, oh, it's A. And then, like, finally, what is 4 over x? Now, you know when you divide something by 0, you can't divide something by 0. So that means x, it can't cross the x-axis. So which of these graphs don't cross the x-axis? Well, that's going to be this one here and that one there. So now you've narrowed it down straight away to 2 possible answers. So in this case, it's positive, so it's going to be H. Moving on. So A, B, C, D are 4 points on the circumference of a circle. Okay, they're on the circumference, so you should already start thinking about circle theorems at this point. It's a circle, it's got 3 points in there. A, E, C, and B, E, D are straight lines. Prove that A, B, ABE and DCE are similar. So let me get my highlighter out. So ABE, where is ABE? So that's that there to there, there to there, and there to there. And the other one is DCE, so that's there to there, there to there, and there to there. Okay, so again, using your circle theorems, you should know that two angles that are opposite to each other are the same. So your first reason to prove that they're both the same, again, they're both triangles. I've highlighted that out. So there's a few ways you can prove that triangles are the same, but if we're going with circle theorems, we should just start by using that. So we know that this is the sign for an angle, so AEB is equal to the angle D, I should just make that a bit more clear, DEC, and here the reasoning will be that the opposite angles, so vertically opposite, we should be a bit clear, vertically opposite angles are the same. Right, so that's the first one done, and then the next one we can look at is that and that one there. So angles in the same segment are the same, and we can say the exact same reasoning about this one and this one as well. They're both in the same segment, so because they're both in the same segment, the angles must be equal. So we would write a statement down here that goes something like, so that'll be ABE, so angle ABE. I'm writing this a little bit fast, so my handwriting's not very neat, and then it'll be ECD are the same, and it's because angles in the same segment are equal. Angles in same segment are equal. The next one is the exact same reasoning for the other one, so we've now got BAE is equal to EDC, and again, you could just write that exact same reason there. And then finally, to prove that they're both the same, three pairs of angles. So since three pairs of angles are equal in both triangles, then ABE and DCE are similar. Using algebra, prove that 0.136 recurring times 0.2 recurring is equal in value to 0.13. Okay, so think back to the recurring decimals topic. So we have x, in this case, is equal to 0.136. So the dot is on top of 3 and 6, which means the 3 and 6 are recurring. If I times that by 10, and the reason I'm timesing it by 10 is because I want to get the recurring part on its own. There we go, now the recurring part is on its own, 3, 6, 3, 6. And now I need to subtract this so I can get rid of the recurring part. I can't do that just yet because the recurring bit here and here doesn't match yet. So if I times it by 10, that still won't match. If I times it by 100, that still won't match. But if it becomes 1000x, and you'll see why I've done this. So this now becomes 136.363636. Now notice this bit and this bit are the same. So now when I subtract the two, I'm left with 990x is equal to 135, where x is now equal to 135 over 990, which is the same as 3 over 22. And now if I come over to the other side, this one's a little bit simpler. So we have x is equal to 0.222. Again, my aim is to get rid of the recurring part. So if I make this 10x, and in this case, it's already the same now. So this bit and this bit match up. So that's 9x. If I subtract the 2, is equal to 2. So that now becomes 2 over 9. And then if I did 3 over 22 times 2 over 9, that gives me 1 over 33. 17. O and Q is the sector of a circle with O and a radius of 11. Okay, cool, so the radius is 11. So we know that this total distance is 11 centimeters. A is a point on ON and B is a point on OQ such that AOB is an equilateral triangle. So again, if you think back to equilateral triangles, straight away we know all angles are going to be 60, 60, and 60, and it's told us the sides are, of course, it's equal, so it'll be 7, 7, 7. And now you want to start thinking in this way. So because we know this is 11 on this side, we know that this is 7. That means we can figure this bit out, because that must be 7 minus 11. So that will give me, I'm not sure if you'll need it, but we can just write that on. That must be 4. And it's saying calculate the shaded region as a percentage of the area of the sector of ONQ. So in order to work out the shaded region, I need to calculate the full region. So if I write that down here, so I need to find area of OQ, however they're setting the calculate ONQ, and I need to find out the area of AOB. Once I find out the area of these two, I can subtract them, and then I'll know what the area of the shaded region is. So the area of AOB is straightforward. We can use the equation of a triangle. It's not going to be a half base times height, because we don't know what the height is. We're going to use the formula half AB sine C. So we're going to use half AB sine C to find the area. So that's going to be half A times B. Those are just the sides, so it's equilateral, so squared, times sine 60. So the area of this triangle is 21.2176 centimeters squared, and on this side, it's the area of a circle is pi r squared. If you don't have a full circle, we have got 60 out of 360, so that's using the angle. That's how much of a circle we've got. So it's going to be pi r squared, we know the radius is 11, times 60 over 360, so that becomes 63.355. Now I subtract the two, and I know the area of the shaded region is 63.355, take away 21.2176, and that is 42.1378. Now notice the question said calculate the area of the shaded region as a percentage of the area of O and Q. So that's going to be 42.1378, divide that by 63.355, times that by 100, and that is 66.5% to one decimal place. Work out the exact value of n. So with this question, you want to start thinking in this way. These all look like powers of 2 to me. So it's saying 2 to x, 16 to the power of 1/5, and 2 to the power of 8. And what I mean by that is 16 can be written as 2 times 2 times 2 times 2 times 2. And you'll see in a second why I'm doing this. So that becomes 2 to the power of 4. 8 can also be written in powers of 2. And that becomes 2 cubed. So now the question becomes 2 to the power of 4. We've still got the 1/5 on the outside. We'll leave that there. Oh, let me just write that a little bit clearer. Times 2 to the power of x is equal to 2 to the power of 3. And then 3/4 is still there. So now let's multiply out these powers. So that's going to be 2 4/5 times 2 to the power of x is equal to 2 9 over 4. Now, when you're working with indices, multiplying indices is the same as adding them. So this can be, if you look at just the powers, 4 over 5 plus x is equal to 9 over 4. So that's how you figure what x out. So what do you add to 4 over 5 to get to 9 over 4? So you can do 9 over 4 minus 4 over 5, and that's 29 over 20, which is 1.45. 19, so we have 2 minus, so we've got some algebraic fraction. It can be simplified to that form. A and b are integers, work out the value of a and the value of b. So again, whenever you have fractions, in this case, well, one of the first things I can spot just looking at this, again, this is sort of being switched on with the maths brain, is that's the difference of 2 squares. That's the same as writing that. Now, we don't need this information right now, but that information might be handy later on. So that's the difference of 2 squares there. So if I write this out, so we have 2 minus x plus 2 all over x minus 3 minus x minus 6 all over x plus 3. Now I want to make the denominators all the same. So I'm going to start with the second and third one first. So in order to make the denominator of the second and third the same, I need to multiply this by x minus 3 and x minus 3. I need to multiply the middle one, so that's coming from here. And I need to multiply the middle one by x plus 3 and top and bottom by x plus 3. We can leave the other one for now on the side. And remember, when you're multiplying top and bottom by the same thing, it doesn't do anything because multiplying something by 5 minus x over 5 minus x. Now these two are just 1, so it doesn't do anything. It's like multiplying something by 3 over 3. It doesn't do anything. But we're just doing it to simplify our life. So that then becomes 2 minus x plus 2, x plus 3, all over x minus 3, x plus 3, and that's x minus 6, x minus 3, all over x plus 3, x minus 3. Now notice the denominators on both of them are the same, so we're getting closer now. And now we're left with the number 2. We also want the number 2 to have the exact same denominator. So now for number 2 to have the exact same denominator, we're going to have to multiply the top and bottom of just the number 2 by x minus 3, x plus 3. We're going to have to do that to the top, and underneath it is just 1. Writing any number is the same as writing any number over 1. So that'll be times the bottom by x minus 3, x plus 3 as well. So that then becomes 2 all over x minus 3, x plus 3, and x minus 3, x plus 3. And I can just copy, in fact, I can just do something like that. I think I can just copy that and paste it there. Awesome. There we go, saves me having to write that. So that now becomes that. Now notice all the denominators are the same. Because all the denominators are the same, I can now write that as 2 bracket x minus 3, x plus 3. The denominators are all the same, so they now just become x minus 3, x plus 3, and then minus x plus 2, x plus 3, minus x minus 6, x minus 3. Now we're getting closer to what the question asked us for, but remember what I told you about this. I'm going to cross this out and I'm going to write this as the difference of 2 squares, so that's the same as writing x squared minus 9. So we're almost getting closer and closer to the question now. We just need to expand all of this out, and let's get cracking with expanding this. When you expand this out, remember I can rewrite this as well, because x minus 3, x plus 3 is the same as writing x squared minus 9. So that will become 2x squared minus 18 minus, so in this case it'll be x squared plus 5x plus 6 minus x squared, so that'll be minus 6 minus 3x, so that's minus 9x plus 18 all over x squared minus 9. So if you now expand all of that out, so that'll become 2x squared minus 18 minus x squared plus, no, that'll be minus 5. Yeah, just careful with the minus here. It's very easy to make a mistake. And then that'll be plus 9x plus 18 all over x squared minus 9. So now if I collect the terms, I'm just going to use my highlighter here just so we are clear. So there's that one there. Let me just make my highlighter a bit bigger. There's that one there, which is an x, and that one there. Now, if you look at them three, that's 2x squared minus x squared minus x squared, so that becomes 0. We can just cancel all of that out, so we don't have any x squared terms. That's good, because the form the answer wanted it in doesn't have any x squared terms at the top either, in the numerator. So if I get my highlighter again, if we now look at the x term, so that's minus 5x, and we have plus 9x, so that becomes, if you look at just the yellow bits, that becomes 4x, and finally we are left with minus 18, minus 6, and plus 18, so that gives us minus 42 all over x squared minus 9, and the question wanted this in the form ax plus b over x squared minus 9, so a is 4, b is minus 42. The diagram shows part of the graph y is equal to x squared minus 2x plus 3 by drawing a suitable straight line. So careful, it does say straight line. Find the estimates, so that means there's more than one. estimates, it's got an s on the end, for x squared minus 3x minus 1 is equal to 0. So if you look at what the question gave us, the question gave us y is equal to x squared minus 2x plus 3. And if you look at what we're being asked is for x squared minus 3x minus 1 is equal to 0. So how do I go from here to there? Well, the x squared bit is fine, I've got that. So that's x squared. Now, in order to get the minus x, I must add 1 here. So that then becomes minus 2x. And then in order to get the plus 3, I must add 4 here. So that will be 1x. And that becomes plus 3 is equal to, let me just make sure I'm using the same color, is equal, well, if I've added x plus 4 on this side, I must add x plus 4 on that side. And then I know what line I now need to draw. The line is x plus 4. So if I was to plot some points on the graph for the line x plus 4, so when x is 0, y is 4, so that's that point there. So the line is y is equal to x plus 4 that we're drawing. When x is 1, y is 5. When x is 2, y is 6. Hopefully you can see a pattern here now. Let me get my ruler. Draw this line through these points. We want to be as accurate as we can. So that would be something like that. And then it says when this is equal to 0. So the estimates of the solution are when this crosses that line. So it crosses, and again, we want to be a bit accurate. So it crosses right there, which is around 2 point, no, sorry, it's not 2 point, it's 3.3. It's around 3.3. And the other one would be, if I go right there, just past minus 0.2, so it's like there. So I'd say it's minus 0.25 and minus 0.25. And that one. So those are the 2 points. Now I'll leave my ruler there because I'll need it for the next one. It says P is a point on the graph such that y is equal to x squared minus 2x plus 3, where x is 2. Calculate the estimate for the gradient of the graph at point P. So when x is 2, so if we come here, that's going to be right. So that's the equation in there, where x is equal to 2 is right there. And it says calculate the estimate for the gradient at point P. So we're going to draw a line at point P to work out the gradient. So if I now come over here and draw a line at point B, that would be through there. So we will use some nice points. We've got one nice point right here. Let me just use a different color. And we've got one nice point right there. So if I draw across, so that is going across by roughly 2, and it's going up by 1, 2, 3, 4. So that's 4 divided by 2, just 2. So it's normally the change in y by the change in x. That's how I've done that. Next one, let me just get rid of my ruler. The diagram shows 3 identical circles inside a rectangle. So that's key there. It's inside a rectangle. In a square, all sides are the same. In a rectangle, they're not. So each circle touches the other 2 circles, and the side of the rectangle are shown. The radius of each circle is 24 millimeters. Work out the area of the rectangle. So the area of the rectangle is just going to be the width times the height. So let's start with the width. Well, we know the radius of the circle, like that, is 24. This bit here is also 24. This bit here is 24, and this bit from there to there is 24. So straight away, we know the width is going to be 24 times 4, which is 96. So we figured out the width, I'll rub that off. Now for the height, you might think, well, can we not do the exact same thing? Now it can be tempting to think that, but if I do from there to there, that's 24, that's fine. But if I go from there to there, that's also 24. And then if I go from there to there, that's 24. And there to there is 24. But it's not quite 24 because if you look, it overlaps there. That bit there and that bit there overlap. So it's not actually 24 and 24 there. So what we have got is the top bit's fine. So that 24 there, let me just get my highlighter. This bit's fine. This bit's fine. But what we now need to find is this gap here, this gap, this height here from there to there. Now, in order to find the gap from there to there, if you connect the three dots together, you get a triangle. Now, you know the base of this triangle is going to be 24 from there to there, and that side is 24. And now I need to figure out what this height from here to here is. So I need to find the height of this triangle. And what I can do is cut this triangle in half right down the middle. I need to find that height out. I know that's a right angle. I know that this angle must be 60 degrees because it's an equilateral triangle. All sides are the same because the distance from here to here, this diagonal distance, if I draw that on properly, from here to here, that's still the radius, that's still 24. That diagonal distance is still 24. So because all sides of this triangle are the same length, it's equilateral. So that angle there is 60. So if I was to draw that bit out here that I've drawn there, oh, let me just draw that a little bit better than that. There we go. So that's right angle there. So if I now draw this on, so that's 60 degrees. That's my right angle. That's 24. And this is the bit I'm trying to work out. So if I use SOHCAHTOA, that's going to be opposite, hypotenuse, and my adjacent. And this is what I'm trying to find. I don't know what this is, so I can ignore that. So that leaves me with tan 60 is equal to the opposite over adjacent. So that means the opposite is equal to 41.5692. And again, always sense check your answers. And what I mean by sense check is, does that seem reasonable? Yeah, it does, because I said the distance from there to there is 24 plus 24, which is 48. And that was with some overlap. So if that's 48, it must be less than 48. And that answer we've gotten is less than 48. And so that seems reasonable. So then that means the height is going to be 24, which is that bit up there. That 24 from there, so that'll be 24 plus 24, and then the bit in the middle, which is now this height here, and that is going to be 41.5692, and that gives me 89.5692, and then the area is going to be the base times the width times height, which is 96 times 41.5692. They want the answer to three significant figures, so that'll be 8,600 millimeters squared. Here are the first 5 terms of a sequence. Find an expression in terms of n. Okay, so we have 4, 11, 22, 37. Let's find the difference to see if it's linear. So to go from there to there, we are adding 7. And then to go from there to there, we are adding 15. Sorry, we are adding 11. And then from there to there, we are adding 15. Now that's not linear because they're not going up evenly. So this means it's a quadratic sequence. What's the difference from there to there? That's 7 to 11, that's plus 4. From there to there, it's plus 4. Okay, now a quadratic sequence looks something like this. Bn plus c, it's in this shape. Now, to get the value of a, you have to half this, so that's going to be 2n squared. And now we're going to write the sequence out. And the n value, so n, the first one, second one, third one, and fourth one. And here we're going to write the sequence, which is, use a different color for that, which is 4, 11, 22, 37. And then finally, down here, we're going to write 2n squared. So when I do 2n squared, which means 2 times 1 squared, that's 2. If I do 2n squared here, that's 2 times 2 squared. So that's going to be 2 times 2, which is 4. And that's going to become 8, and that's 18. So now, well, how do I go from here to here. Well, I need to add 2. How do I go from here to here? I need to add 3. How do I go from here to here? I need to add 4. So I'm almost there, but it seems like I need to do 2n squared for the sequence plus something. But if I did plus 1, that's not going to be quite right, because for the first one I'll end up with 3 instead of 4. But I also need to add n to this, so that becomes 2n squared plus n plus 1. And for the final question, so x squared plus y squared is equal to 4, p, 3 over 2, root 7 over 2 is a point on L. Find an equation for L at the point P. Okay, so we know it's a circle, so let's draw that here. Ooh, not this. Yes, that can sort that out for me. That is a nice circle there. Now let's draw some lines on this circle. So we split that into 4 quadrants. So if I use my pencil tool, there, and there, nice. So the first thing you want to bear in mind is that the formula of a circle is x squared plus y squared is equal to the radius squared. But in this case, they've told me this bit is 4. So I know 4 is equal to the radius squared, which means the radius is equal to 2. So that means that can be 2, the distance from the center to there. They've also told me P is a point 3 over 2, root 7 over 2 on L. So there's a point on L somewhere. Well, if you look at this, if that's the y-axis and that's the x-axis, we know that x is 1.5, which will be somewhere here. Let's just say it's there, 1.5. And we know y is root 7 over 2. If you type that in your calculator, you'll get a value for it, which will be somewhere there. So we know that point is somewhere over here. If I draw a straight line, that is point P. So it says find the equation of the tangent to L. Now the tangent is a line that touches the circle at 90 degrees. So that would look something like, again, you can use your ruler for this. If I just get my ruler out, it's going to be at 90 degrees to this. That looks about right. If I use my pencil again, I think that, there we go, that's drawn something on for me. So that's at 90 degrees. So a few things to bear in mind here. The equation of a line is y is equal to mx plus c. Is the equation of a line. Let me just write that one down. Just draw a line there. So this is separate mx plus c. That's the equation of a line. Now, we have 2 points on that line for P, so that's root 3 over 2, and we've got the other one. So to work out the gradient of this line, we can do, so the gradient m is the change in y over the change in x. So we know, if I was to draw that here, so that's the change in y, and that's the change in x. So if we do the change in y over change in x, so that would be root 7 over 2 divided by 3 over 2. So the gradient now becomes root 7 over 3. So now I know what the gradient is. I now need to find the gradient of the tangent. Now, the tangent, like I said, touches that line at 90 degrees. So there's another formula, which is m1, m2 is equal to minus 1. So what this formula is saying is the gradient of one line times the gradient of another line is equal to minus 1 when they're perpendicular. So we know the gradient there is root 7 over 3. We're going to times that by the line. The other gradient, so that means the other gradient must be equal to minus 1 divided by root 7 over 3, which is minus 3 over root 7. So now we know the gradient of the other line. We need to find what? We can write the equation as, so the final equation is going to be y is equal to minus 3 over 7x plus c. But we still need to find what c is. But we know they both share one point in common, and that's point P. So if we shove in the coordinates for point P into this equation, we end up with root 7 over 2 is equal to minus 3 over root 7, and x at this point is 3 over 2 plus c, which then, when you times them out and rearrange that, you end up with c is equal to 8 root 7 over 7. And then we can write the final equation as y is equal to the gradient, which is minus 3 over 7, x, and now c is 8 root 7 over 7. So hopefully you found that useful. That was a run through the 2017 higher paper 2.